Everybody's at the end of Roman numeral 6 with our example problems, right? There are 5 of them. On the first example question, we've got Boy Scouts hiking straight up a trail. So we're just assuming that it's not winding at all. It's just going to go straight. And it takes 3 days to complete. So what we're going to do is look at how many miles they travel each day and find their displacement. And on the first day, they are able to walk 10 miles. And you can pick any direction you want to is up. I just kind of imagined like a little sloping hill a little bit. So that would be 10 miles on the first day. And then they start in that same position where they ended on day 2, and they continue up the trail. So on the second day, they keep going. And it's not quite as big of a vector. It's a little bit smaller because they only went 7 miles. And then on the third day, they wake up and they're in that same position where they ended the night before. And they walk a little bit more. And this one, they're able to walk 4 miles. So when it says draw a vector diagram of their hike, that's the part that we just did. Okay. So all the vectors line up head to tail next to each other. Their displacement, in this case, would be equal to the resultant. So when it says displacement, we're looking for the vector sum of all of those things. So our vector sum, in this case, would be equivalent to, let me move this up a little bit. The vector sum would be equivalent to where they started all the way to where they finished. And how many total miles would that be? Okay, 21. So their displacement, they started down here, and it points to where they finished up at the top of the trail. Okay. So if your vectors are all in the same direction, you just simply need to add them together. And we've shown a direction because we drew a picture of an arrow pointing in a particular direction. So the 21 miles is considered the magnitude. Okay, that might be a new word for you. It's just the size. So the 21 miles, that total is our magnitude. And then our actual vector is this whole thing, and we have a direction indicated by the arrow. Okay, so that would be our final answer. That's all you would need to do for that one. Okay, yes?
Do we have to write like plus 21 or something?
If you had indicated that that was a positive direction, you can do that as well. Okay. Yeah. If you drew an arrow that indicated that, then you don't have to. But if you didn't draw this final vector, I could have just said plus 21 miles, and the plus sign would take the place of the vector. So that would tell you a direction. So if you don't draw a picture, yes, you need the plus sign. Anything else, other questions on that one? Okay. So our second one, we've got 2 people out 4-wheeling and one of them gets stuck. Okay. We haven't studied forces yet, but they are going to be vectors, and it's a push or a pull. So in this case, we've got one truck pulling on another vehicle to try to get it out of the mud. And in this case, your vector diagram, you can choose which direction is each of those values. It doesn't specify that one's to the right or one's to the left, but we can use positive and negative to indicate right and left. So I'm going to say this direction is my 24,000 newtons. It's listed first, so I just picked it to be 24,000. And I'm going to say that to the right is the positive direction. So again, we drew the arrow, but you could also indicate it with a plus sign. And then my other vector, it's a little bit bigger, so I want to draw it longer than the other one, and it's 28,000. And again, I drew an arrow in my picture to draw the actual vector diagram. I can also indicate a direction by putting a minus sign there. The resultant for these two, because they are in opposite directions, you do actually subtract them. Okay. So if I did negative 28,000 and 24,000, what's left over? Yeah, 4,000. So which way is that 4,000 pointing? Yeah, in the negative direction. So I can either write a negative sign, and that tells me it's back to the left, or I can draw an arrow as a vector and show that it's pointing to the left. So it's an either or. If it helps you to remember to do both, you're certainly welcome to do that. Okay. And remember, it did not specify which vector was which. I just happened to choose the 24,000 to go in that direction. Had you done it the other way, you could show it like this one, and I picked the larger number to be in the positive direction, and then my final answer would also be in the positive direction. So it's up to you to choose that coordinate system. So whichever one you pick, it's got to match your system that you picked, that you set up at the beginning. Okay. Is there anything on those that you'd like to go over? Okay. So we know that there's a 4,000 Newton difference between these two numbers, and remember, you specify the direction based on how you set up your coordinates. Now we've got some that are at right angles to each other. Okay. So we started out where all the vectors were in the same direction. Our next one was when they were in opposite directions. Now we're going to use right angles. So our first one, we've got a person hitting a baseball due east. So I would draw a vector that points to the east, and that one is 60 meters per second. And then I've got a wind that's providing a vector north at 5 meters per second. And I know in that video that I showed you two methods on how to add vectors. The tip to tail or head to tail method's a little bit easier, I think, so I'm just going to use that one in the examples. So my second vector, it's not quite as big, okay, and it's pointing north, and it was 5 meters per second. That's 5.0. Okay, didn't show up very well. These types of vectors, to find your resultant is actually pretty simple. If you have one vector that's east and one that's north, your resultant is a combination of those two. And it's going to point from where we started back here, and it points to that final spot. And that vector sum is called a resultant, so I can just label it with an R. Okay, so you can see that when we're using these compass directions, it makes a right angle. Your resultant will always be the hypotenuse. That's something that will kind of help you. The resultant's always going to be the hypotenuse. So you'll have two of the legs of the triangle, and you're finding that larger edge. And you do use Pythagorean Theorem. You guys were correct. So, all my pictures stuck together. I'll just write it out. It's fine. I had it already typed pretty for you, but you have to deal with my handwriting. Okay. So I would say that the hypotenuse squared, okay, is going to be equal to the 2 legs squared. And we'll type that out real quick on the calculator. And that gives us 3625. And then you'll want to take the square root to get your final answer. And this one, our resultant, is going to be 60.2. Okay. And what units were used in those numbers in the problem? Good. So that means that your answer is going to have meters per second as well. And then what direction did it point? Northeast. So we want to include that as part of our answer. Okay. Good on those? Okay. Ask you to find the angle. It would be like this little tiny one right here. Okay. Have you seen that symbol before? Yeah. Okay. So this is the Greek letter theta, and it means an angle, just in case you haven't seen it. And we would use SOHCAHTOA, sine, cosine, and tangent. Okay. I'm going to pick tangent just because. Okay. Let's say for some reason you messed up on the hypotenuse. You know the other 2 legs are correct, so I'm going to pick those because I know they'll be the right numbers. Okay, something that's going to be maybe a little bit new to you is we would have the inverse tangent. So if I said the tangent of my angle is equal to the opposite leg over the adjacent leg, okay, then I would say the tangent of the angle is equal to 5 over 60. Well, when we're rearranging this, we can't just say divide by tangent. That doesn't mean anything. We want to do the opposite function of the tangent. So what we're going to do is take the inverse of tangent. And the way it looks when you write it, we would say the angle is equal to its tangent to the minus 1. So that means we're taking the opposite function of tangent. And then our fraction. You could have made that a decimal and divided it out if you wanted to, or you can just type it in as a fraction. So on your calculator, when you type, okay, I'm going to give you some little hints here for you. Let me move all this up. Why is that not working? Okay. I'm just going to draw another box over here. So when you're typing on your calculator, you would hit the second button, and then hit tangent, okay. And it's going to open up your parentheses for you, and then you type your number, and then you hit enter. So on your calculator, it'll look like this part down here that we did. It'll say tangent to the minus 1, and then 5 over 60, and then you can close your parentheses and hit enter. Did anybody try it?
Yeah.
What'd you get?
4.6.
Okay. So 4.76. Oops. 7. And then you would put a degree sign. Okay. Something that you want to keep in mind, I'm just going to put a little star here for you. You want your calculator in degree mode. I know some of you may be in pre-cal or something like that, and you might use radians, okay? So you'll want to make sure that you switch back your calculator to degrees when you're finding these answers. Okay? If I had been in the wrong mode, I'm going to go down and tell you what that answer would look like. If I had been in radians, I would have gotten 0.083 as an angle, and that's really, really, really tiny. I know that the wind didn't really blow that ball very much off course, but it is going to blow it off course more than a degree. So just kind of clue yourself in. If you're trying to find an angle for something and you get less than 1, or sometimes you'll get a negative number, go back and check the mode on your calculator. You definitely want to be in degrees. That's going to be really important. Okay, so degree mode on your calculator. So on this next one, I have an example of drawing a map. And next class, we're going to do a pirate treasure map, and you're going to be drawing your map. And you'll get to be silly and make pirate sounds. Okay. I need to have something to entertain me, so I'm going to giggle at you. Okay. So this particular example, whenever you see questions like this where you've got several vectors, but they're changing directions, you want to draw them as in proportion as possible. So I'm going to delete this little box and show you the vectors that we drew. So I'll kind of trace it with you. I started here. Okay. The first vector given was 4 blocks to the south. So I drew it down going 4. Okay. And then I went 3 to the west, and I just connected head to tail. And this was another reason I thought head to tail method was a little bit easier, because when you have more than one vector, that's really the only way you can line them up. So I went 4 south, 3 blocks west, and then we go 6 blocks north. And see how the 6 vector is taller than the 4 vector? So that helps you to be in proportion. Okay. And then we're going to go 7 to the east. Okay. So I had started right here. And then our trip ended here. Okay. my resultant points from where I start to where I ended. Okay. And then notice that little dotted line that I drew for you right here? What that does is if I'm asked to find the length of this resultant, I can put a dotted line in here and create a right triangle. So now I have a right triangle. So over to the side, I'm just going to redraw a triangle that's just this little section. And we'll kind of work with that one. So this length of the triangle, that's just referring to this spot right here from the dotted line over. Can you think of the length that that would be by looking at your picture?
4.
Perfect. I'm so excited. And then what about this one? 2. Okay. So now I've got a right triangle that has one length of 4 and the other leg is 2, and we're looking for the hypotenuse. Remember, the hypotenuse is what our resultant was. Okay. Can you do Pythagorean theorem with those? Do I need to write them out for you? Okay. Okay. So if you did Pythagorean theorem, you should get 4.47 blocks. Okay. And then look, I also included a direction to show that my resultant overall from start to finish pointed northeast. So you need to have a direction in your answer. This is the kind that you'll be doing on your lab. Okay. And then the other examples I've got a worksheet and we'll practice with that as well next class. And we've got one more. Okay. So let me cover these up for you. Hang on. So on this one, I've got somebody mowing the yard and they pushed downward on a mower, so I drew my resultant going downward, and it says add an angle to the horizontal. That means that the angle I drew in touches the horizontal. Okay. And I'm looking for the x leg. Okay. From your notes, you can look up that the x leg is going to be equal to the resultant times the cosine of the angle. Okay. And another little clue for you, if you're ever given one number and an angle, the number that's not the angle will be the hypotenuse of a right triangle. Okay, so that's going to be the hypotenuse. And we're looking for the horizontal and vertical components. Those are just legs to the triangle. You don't have to say which direction they are. It's going to be implied that it's horizontal or vertical. And I could have drawn my picture pointing downward to the right instead of downward to the left. So it's really just finding the length of those sides. And when we go to plug these in, I would say that x equals, my 15 number was the one for the hypotenuse, that was the resultant, and then cosine of 30. And on this one, it's really nice because you just type as is on your calculator. You can hit 15 cosine 30 and close your parentheses, and it'll give you the answer. You don't have to do any inverses or times or anything like that. And you should get 13 newtons. Again, I'm going to give you a little bit of a star here to remind you that you want to be in degree mode on your calculator. And then the vertical part of the triangle is going to be sine instead of cosine. And again, you just plug the numbers in. The numbers go in the exact same places as they did before. You're just typing sine instead of cosine on your calculator. Okay. And if you're following along and you practice on your own calculator, you should have gotten 7.5. So when it's asking you for the components, you don't have to include the direction on those. We know that x is horizontal and y is vertical. Okay. Those are the 5 different types of examples you're going to see. Any questions? There is a last page. On all the notes you print out, I'm going to have a study guide for you. Okay. On your test, you're going to have multiple choice questions. So it's going to be definitions, and I listed some definitions for you right here. Okay. And then I kind of went through the notes a little bit and just highlighted some of the other things that we talked about in the videos. Okay. So all the parts that are up here, I'll turn those into multiple choice questions. Okay. And then you also will have a free response section. That means I might have like fill in the blank or math problems or something like that for you. So basically anything other than multiple choice will be in the free response section. And the types of things you'll have to know on your test are how to rearrange equations and solve for a given variable. You'll have to know how to read and interpret a graph. So find the slope of a graph. Okay, would you be able to do that? That's the type of thing I'm asking you for. You'll also have to draw the pictures of your vectors. So the one dimension would be where they're parallel to each other. They're either both in the same direction or they're in opposite directions. And then the 2 dimensions would be our right triangles. Okay. And then you'll have to calculate the resultants. You can use Pythagorean Theorem if you're finding the hypotenuse itself, or the components, which would be the x and the y leg of your triangle. So they'll look like the examples that we did together. Okay.